So hopefully you got a good start on many of these. If not, you may have to go back and finish some of them. I was going to look at a few of them with you before we got started on some more practice today in that packet I just gave you. So let's look at these evens here. These are from the first example when we have whole numbers, and we just need to move our ends to one side or the other. Guys, are we done, please? 135. All right. So do we want to subtract 3n from both sides? Or do we want to subtract 5n from both sides? All right, so I guess I'll choose. I would subtract 3n, but you could do it the other way. Whatever you do to one side of the equal sign, you have to do to the other. If it helps you to draw a line here, do that. Noah, please close your Chromebook. Get out your workbook. All right, 14 plus nothing is 14. 3n minus 3n, that went away. Bring down your equal sign. 5n minus 3n is 2n. Bring down your minus 6. Now we have a two-step equation, so we get rid of this constant. Lucas, can you please move? I don't like when your back's to me and you're constantly talking. It's disrupting my train of thought, kind of like these boys who are constantly being obnoxious. Please stop. Jackson, please stop. We're on page 135. So I'm getting rid of this constant that's on the side of the variable, so it goes away. So I'm adding 6 to both sides. 14 plus 6 is 20. Bring down your equal sign. Bring down your 2n. This became 0. Now if we have 2 of something that equals 20, we would divide that something by 2. So 20 divided by 2 is 10. 2 divided by 2 is 1. 1n is just n. So 10 should be n. If we go back and look at our examples for our fraction, we would see that we need to change these into common. Move. Go somewhere else now. Far away from him. And don't sit next to him ever again. We have to find common denominators. So I have a 3 and a 6. Can 3 go into 6? Yes, so we can change them to 6. So we have something out of 6y plus 1 equals, this can stay the same, it's already 16y plus 8. So we just need to figure out our new numerator. What did we have to multiply the 3 by to get 6? 3 times what is 6? 2. So that is what I have to multiply the 2 by. What's 2 times 2? 4. Good. Now I have 2 options. I either need to move this over here or move this over here. So I'm either subtracting 4/6y from both sides, or I'm subtracting 1/6y from both sides. What looks like it would be easier? 1/6y. Subtracting 1/6y. I would do that. Whatever I do to one side of my equal sign, I have to do to the other. This just moves it so we only have a variable on one side. 4, 6 minus 1, 6 is 3, 6. You can leave it like that, or you could change it to 1/2 if that makes it more simplified for you. 3, 6, bring down your +1, bring down your equal sign. This, Jackson, move somewhere else now. No, I've had to talk to you at least twice. You can move. This becomes 0. Go power about it. Bring down your 8. All right, now I have to get rid of my constant. I'm gonna rewrite this up here so I have a little bit more room. 3, 6y plus 1 equals 8. I have to get rid of my constant. So I'm gonna subtract 1 from both sides. I have 3, 6y equals 8 minus 1 is 7. And now this might have been helpful for us already to change this to 1/2. It doesn't matter. You can multiply by 6/3, but I think it would be easier to multiply by 2/1. Remember, we multiply by the reciprocal. It's kind of hard to see in that green. But 7 times 2 is 14. Divided by 1 is still 14. So that means y is equal to 14. You could have said 7 times 6 and then divided that by 3, but. All right, decimals. The same thing. We have to move our variable terms so that they're only on one side. Do we want to subtract 1500ths W from both sides? Or subtract 2200ths W from both sides? 22. You want to subtract the 22, so it's going to be negative. Okay. So that would become 0 here. This goes away. We bring down our 3500ths. 22 minus 15. Well, I can't take 5 from 2, so I would borrow. So I have 700ths. There's a decimal here. Bring down this. And we have a two-step equation. So now we're going to add this to both sides because we're looking at what's tied to our W. We've got to undo this subtraction. So I have 4900ths. Jackson, move to the back. You just move somewhere else to talk to someone else. How is that at all helpful? I understand, but you need to make better choices. Now this is kind of like 49 divided by 7. So this should, so I'm going to divide 0.07. So I would probably throw this into my calculator. 4900ths divided by 700ths. So 0.49 divided by 0.07 is equal to 7. So 7 equals W. All right, so that is a bit of a refresher from yesterday. Be sure that you get these practice in. Today, I want to look at it a little bit differently and see if that helps kind of wrap our heads around it. In this packet, so these are pouches. We're not sure how many coins are in each pouch? So that is our unknown. So that's what we're gonna put for our variable. So this would be x, 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 kind of like the algebra tiles. And how many x's do we have here? Excellent. So if we're writing an equation to represent this situation, we would have 5x plus how many ones? How many coins? 8. And we're saying that equals how many coins over here? Is it 23? It's one less than 24, right? 8, 16, 24 would be all. So 23. So if we were just solving this like a two-step, we would be getting rid of the coins, right? So if I took away 8 coins from this side, I would be taking away 8 coins from this side. And I would have 15 coins left. And these 15 coins, I would be dividing up into these 5 things. So I could count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 times. I can count to 3. I'm sorry, I can count to 5 3 times. Yeah. So that means there are 3 in every pouch. Let's see. There's 1, 2, 3, 4, 5 groups of 3. So these get canceled out and these go into the pouches. In other words, we first subtracted 8 from both sides. We took out these 8 coins. So we said 5x is equal to 15. And then we divided the remaining 15 into 5 equal groups to get x is equal to 3. Okay, so just another way to look at our two-step equations. Noah Nidifer, do you need to go or can you stay?
Every time I say Noah, I get a heart attack. I don't know why.
Because you're used to it being you? I don't know. All right, looking at this backside. Now we have pouches on each side. So the first thing we have to do is remove our pouches. So let's look at what this would look like. How many pouches? How many x's here? 2. So we're going to write this as 2x plus 2, 4, 6, 8, 10. Bring down our equal sign. And then we have how many ones here? 9 plus 3x. All right, now the first thing we can do is get rid of 2 pouches from each side, right? So let's show that algebraically. Subtract 2 pouches from each side. This is going to give us a one-step equation. We still have these 10, and we have 9 plus, and this just becomes 1x or x. So now we have 1 pouch. We have to get rid of these 9. So if I take 9 from this side, I also have to take 9 from this side. 2, 4, 6, 8, 9. And I have 1 left over here. So if I subtracted 9 here and subtracted 9 here, I'm left with 1 is equal to x. Right? 1 pouch is equal to 1 coin. All right, try that. We'll write it together. So we have 2 pouches, so 2x, 3, 6, 9, 12, 15, 18, 21. Our equal sign, we have 1, 2, 3, 4, 5. Plus 3, 5x plus 3. All right, try this. Start by removing pouches from each side, so you get them all on one side. Then remove the coins, then divide. Give that a go. You can use the coins and pouches, you can show it alphabetically, the envelope should be closed, your phone should be thrown away.
My used to,
All right. You need another minute? Okay, thank you for trying. All right. So we have to get all of our pouches onto one side. So what did you do first? You can take these two away and these two away, right? So if I subtract 2 pouches from the left, I also have to subtract 2 pouches from the right. That leaves me with still these 21 coins. It leaves me with 3 pouches. And I still have these 3 coins over here. So now what do I want to get rid of? What did you do, Kaden?
You wanna get rid of the,
So we want to get rid of these 3 coins from the right, correct? So if we get rid of these 3 coins from the right, we're subtracting 3. That means we also have to get rid of 3 coins from the left, so we're subtracting 3 on the left. So now we have 18 coins on the left, and we have 3 pouches on the right. So what's really nice is that we have 3 rows, right? 1, 2, 3. So we could easily divide these into their 3 pouches. How many are in each row? We're not counting these because we crossed them out. So how many are in the top row?
oh, 6.
6, right? So 6 plus 6 plus 6 is 3 pouches. Would that work? So if we divided them into the 3 pouches, each pouch has how many? 6. It's a little bit different, but hopefully it gives you kind of a concrete example of the process. All right, so now comes the extra practice. Without the fractions and decimals, I thought you'd appreciate that. So if you need to draw a picture, do so. Remember, you're going to move the variables first. So either we're subtracting x from both sides, or we're subtracting 3x from both sides. You decide. You want to subtract 3? That's fine. Watch what happens. You'll get better and better at choosing, but it doesn't matter. X minus 3x would be negative 2x, right? And then we want to get rid of this from both sides. So we would add 5 to both sides. So 10 is equal to negative 2x. And then I'm dividing both sides by -2. 10 divided by -2 is -5. X. Okay, so try these, give these a go. This is the time to practice and make mistakes so we can fix them. Get all your pouches to one side, get all your variable terms to one side, and then you have a two-step equation.